In this video, we're going to be looking at ions and what charges they are. Specifically, we're going to be looking at some of our transition metals. But before we go into detail on that, I want to cover some review about valence electrons and charges that ions have in our representative elements on the sides. So if you remember, group 1 has one valence electron. And when they have a charge, they lose that valence electron and get +1. Group 2 would have two valence electrons, and they'd lose those to get +2. In group 13, our metals would lose their three valence electrons to become +3. Our elements here don't really want to, carbon and silicon, don't really want to form ions very much. But as we move over to group 15, our non-metals will have 5 valence electrons and want to gain 3 more to get 8, and they'll have a -3 charge. Group 16, 6 valence electrons, they'll want to gain 2 more and get a -2 charge. And in group 17, all of these elements will have 7 valence electrons, want to gain 1 more and become a -1 charge. And if you remember, our noble gases, anything on this far right side, group 18, they have that full set of valence electrons already, and they don't want to form ions at all. So going into a little more detail, one more thing before we jump in. All of our metals will be positive ions because they're losing their electrons. All of our non-metals will be negative anions. So it gets a little tricky over here when you get multiple types of elements, so nonmetals and metals in the same group. So even though nitrogen and bismuth are both in group 15, bismuth is a metal, so it will want to lose its valence electrons, and nitrogen's a nonmetal, so it will want to gain valence electrons. So we can take a closer look at a different periodic table. I'm going to have to zoom in a little farther on this one. So we're going to take a look at this periodic table here, which has the charges of all the ions for that specific element. And the first thing I'm going to do here is I am going to draw my staircase separating my metals and nonmetals, and you'll see why. Or you may already know why. Once we separate them with this staircase, you will see everything on this side, the left side, is going to form positive ions. All of these elements will form positive ions. And on the right side, you will see they will form negative ions. And of course, there's a few exceptions, and I'll box those right now. Some elements don't want to form ions, so that would be boron, carbon, silicon. Those don't really want to form ions. And then, of course, we have our noble gases, which we know already have that full set, so they don't want to form any as well. And we already know a lot of information on this periodic table. Like we know group 1, they all have a +1 charge. You can see right there. Group 2 would all have a +2 charge. Group 17 all has a -1 charge. Group 16, if you look at the nonmetals, all have a -2 charge. And group 15, if you look at the nonmetals, all have a -3 charge. So one of the big things that's confusing and we haven't learned a lot about it is our transition metals. And if you take a look at a lot of our transition metals, they can be more than one type of ion. So if you take a look at iron, iron could be a +3 ion or a +2 ion. And if you take a look at copper can be +2 or a +1 ion. And something like titanium can be a +4 ion or a +3 ion. And you can see there's a lot of elements all around that have more than one type of ion that they form. So the way that we write this out in chemistry to show us what ion it is we use Roman numerals after the name. So for copper, if I'm talking about a copper that's going to form a +1 charge, I'll just write copper 1. Or copper that's going to form a +2 charge, copper 2. So same thing with my other elements. Iron, if it's a +3 ion, it'll be iron 3, and a +2 ion of iron would be iron 2. So you can see these Roman numerals refer to the charge on the ion. And titanium 4, I and V in Roman numerals would be 4. So titanium 4 would have a +4 charge. And titanium 3 would have a +3 charge. So those are just some examples of what you might see. You're just going to look at that Roman numeral, and that will be the charge on your cation. So now if I give you a metal that's not in one of our groups that has a nice and easy charge to remember, I will give you the Roman numeral with that element, and that will tell you the charge. So that's going to be something that's going to be we're going to see moving forward in this unit with ionic bonds.